Hello, this is Michaela Smith, and I am in the fall 2018 term of Anatomy and Functions of the Visual System. And we're going to talk about some of the major components that make up the eye. The eye is composed of two segments, the anterior and the posterior, basically meaning anterior front, posterior back, and even though it's diagrammed, back here we're going to start with the sclera. This is what you would call the whites of your eyes. It is a tough, fibrous outer protective layer. And since we're on the layers of eyes, let's just move on to the second one real quick. The choroid is the second layer. It is right under the sclera, and it is a dark pigmented layer, and it lies between the retina and the sclera. And it consists mainly of blood vessels that will nourish the retina. So now the retina is the third layer down. And this is the inner lining of the back chamber of the posterior of the eye. And it contains what we call photoreceptors, which are called rods and cones. And these are two very different cells. Cones provide the detailed vision and color, and rods provide our night vision and our global movement. And all of this receives the light rays that come through the pupil up here, and we'll get to the pupil in a minute. And that is converted into impulses that are then relayed to the brain, but we'll come back to all that in a little bit. So up over here real quick, we have the ora serrata. This is the inner eye where the retina will end and the choroid layer of the eye can be seen. And then we'll move over to the conjunctiva. You can see here how it's showing that it's out a little ways. That is because it is a clear membrane that covers the front of the sclera, again, the whites of your eyes, and it also lines the inner part of your eyelids. And this is where we get the term conjunctivitis from, which is also known as pink eye, which is just basically inflammation of the conjunctiva. I'm pretty sure at my house at any given time, pink eye is dripping off some little fingers. Now we'll cover the rest of the interior segment of the eye. Down here we have the cornea. It is the front transparent part that is the outer protective layer of the eye. You might also call it the clear space you see on the eye. And it's curved. You can see how it's curved so that it'll provide the major refraction or strength of the eye. So next we'll move on to the iris. We have the iris here and the iris here. That is the colored or the pigmented portion of the eye. This contains the pupil. The iris contains the pupil. And the iris controls the amount of light entering the eye by enlarging or minimizing the pupil. So now the pupil, which is obviously the round hole in the center of the iris that we just discovered, this is where light passes through. The pupil will appear black because there is very little light coming from the dark chamber behind it. And what some people may not know is that the pupil is not a hole. The pupil is a hole, I'm sorry. It is not something that you can touch. That is something I did not know. So down here, and in the anterior chamber, we have the aqueous or aqueous humor. It is a watery fluid that fills the anterior segment of the eye. It's constantly being produced and drained out, and it helps bathe and provide nourishment to the lens, to the cornea, and to the iris. And it also maintains our inocular pressure. So with the aqueous, we can go over to something I'm going to add that's not on here. It's called the trabecular meshwork. I'm mixing the words up, which isn't labeled on here, but it is a filtration band on the outer rim of the iris where the fluid will flow through it before it enters the canal of Schlemm. This is probably my favorite part of the eye just because it's the most fun to say. The canal of Schlemm is a collection canal that removes and delivers all the aqueous fluid to the venous system. Now we'll move to the lens, which is obviously behind the cornea, behind the iris, and behind the pupil. The lens is very resilient and transparent structure in the eye that focuses the light by changing the curve of itself. Kind of reminds me of the shape of a contact. So basically the lens will get fatter when we focus on something near or thinner when looking at something farther. That is also called accommodation, and this is where cataracts occur. The lens of the eye will become cloudy or opaque. Next we'll move to the ciliary body. The ciliary body are muscles that are attached, up here and down here, to the iris. This is what controls the focusing of the eye. So it works on the accommodation of the eye that allows the lens to get thicker or thinner. And then between the lens and the ciliary body, right here we have the suspensory ligaments. These are long, thin fibers that connect the lens to the ciliary body or ciliary muscles. So now we move on to the rest of the posterior segment of the eye back here. All of this is filled with vitreous back here, or vitreous humor, which is a clear jelly-like substance that fills the posterior segment of the eye, all behind the lens. So back here we'll move to the macula, which is a small thinned area of the retina that contains exclusively most of the cone photoreceptors. This is what helps with our high visual acuity. Then right here, it's pointing to the little indentation here. We have the fovea centralis. It is the central part of the macula, and it has the highest concentration of cones, and it is the only spot where we have 20/20 vision. It is also the place that can affect color blindness and is the center of our vision. Here we have the optic disc. This is known as the blind spot in our eye. This then sends impulses from the retina, all where the dots are, from the retina to the optic nerve. Back here, the optic nerve. That is a bundle of fibers that carries vision-related impulses and action back to the brain. I don't know about you, but I think, the way we see and the way the eye works is pretty simple, right?